In this tutorial, I'm gonna give you a quick demonstration on how to set up your Kinect camera with ofxOpenNI for OpenFrameworks. So the first thing you need to do is you need to download the actual source files from the gameoverhack/ofxOpenNI from GitHub. So you can either clone or download the zip file from here. And let's get started. So what I've found was the hardest thing about getting this up and running is actually making the library work, because it's not as easy as you normally, if you just add an add-on in your project generator. That's very simple, but this is a little bit more complicated. So I'm going to give you a little quick way how to do this. So if you open up, so this is ofxOpenNI add-on folder, which you get when you download it. So this is how it looks. This is the structure, and the things, the folders that you need is, because there's a lot of things in there, examples in here, there's just a bunch of stuff, and there's some really good instructions on these on the GitHub itself, but it could be quite tricky, and I had to go. Myself had to go through different bunch of forums and just try to get. What I'm going to show you in the end of this tutorial is I'm going to show you a skeleton tracking. You can track your skeleton with this, because it's not really an example that comes with it. It comes with a bunch of examples like hand tracking, stuff like that, but it doesn't really give you that skeleton that you associate with the Kinect camera. So I'm going to show you how to do that really quick, hopefully. So the files that you need is the source file, which is all the source files from the library, and then you need the folder that's inside this Mac folder. It says here copy to data OpenNI path. Yes, makes sense. It's in the instructions. So and this lib has all the dynamic libraries that you need also for it to be able to work, and also the include file here, with just tons of, because this is a wrapper and it's tons of different files that you need. So what you need is that the include, you need the lib, and you need the lib, and you need the source. Those are the three folders that you need from this OpenNI folder, from the add-on. So what I did to be even clearer, I made a separate folder inside my add-ons folder on my OpenFrameworks. I added a new folder called ofxOpenNI new, which I just took these, copied and pasted these three folders into a new. So there's no examples, there's nothing to confuse you. So these folders holds all the other files, and with all the structures that you need. So with that, we need to just create on your project. So I have my project generator here on my desktop. So let's say skeleton test, like that. You go to your add-on, so if you look here, I have ofxOpenNI, but I also have ofxOpenNI new, and I'm gonna click on that because that's the files that I need. They hold the same thing, but just to be super clear that everything is going on, this is how I do it. You go back, and we generate it. It's cool. So let's go. So let's find it here. Let's open this up. So before we even start doing anything fun stuff here, the first thing we need to do is that we need to, if you go into our skeleton test folder here, we need this bin needs to be replaced, and that's why we go back to our ofxOpenNI, and here we go to the examples. So if you click on the example, I have it open here. So here's everything that is in the examples folders, and what you need is that you need to take this bin folder in here and replace that inside, because this bin holds First of all, it has a font, which you don't need to use if you don't want to, but it comes as default. He has this file called this folder called config and libs, which is the same dynamic library that you have in your add-on folder. And you see the structure here says bin data OpenNI. So that's the structure you need to have in order to everything to find the right files. So what we do is we take this, we copy it, go to our skeleton test now, our new created project. We go here and we paste it. Oh yes, and we want to replace that. So we're just overriding that bin with our new bin. So if you click on the new bin here, we have data, yes. And in here, we have now these folders. We have OpenNI, which hold these two files. That's all fine. That's cool. So let's do it like that. So when that is up and running, now we have it like that. We let's see. Yes. So now we go back to our Xcode. So first we need to be in debug 64-bit, or I think you can run it on 64, but I think I read somewhere that it prefers to be run on 32. So I'm going to run it on 32 for now. So if you go here, we have the source, you have your mains, everything like that, and you have add-ons. See, ofxOpenNI new, which holds the source file. Boom. This is normally how you do, like, you add a library to your OpenFrameworks project, but if we run this, it's not going to work because we need more stuff in here. So the first thing we need to do is that we need to go to our ofxOpenNI, and we need to drag and drop. So this needs to be from the add-ons folder, nowhere else. So you go to our ofxOpenNI new folder, and we drag and drop the lib and the include file. We drag those into our add-ons folder here, and we do create group, and there we are. So now these files are also included in our project, and we need to do one more thing, is that we need to also inside this OpenNI new folder, click here, we open up the lib, and we need to find a specific file, that one, if I'm not mistaken. Yes, that's the one we need. So we need to take that as well and drag it, and I put it on top here just to make sure that you can see it. So it's on the top of my sketch now. So now the dynamic library is included, all the source files is included. So this will still not run because the architecture is not correct because now we need to define a very specific file path. It's called a header search path. So we need to we click on the target on the main far up to the left here in Xcode on our target. We click on build settings. Let's make that smaller like that. So and here you have a search bar, you search for header, enter. So see on the bottom here we have search path. So if you click on here, header search path, double click here, you can see that. So when we add this add-on through the project generator, this is what's happening. It's pointing to these files in this structure. So what we need to do now is that we need to be able to access. Let's see. We want to be able to access. Wait a minute. This. Sorry, yeah, we need to access these folders because it's gonna complain about not finding I think it's this. It's always going to complain about something if you don't add this header surf path. So that's what we're going to do. So we're going to, and this, as you saw, this is in ofxOpenNI new, same folder as the source, which is, so the header surf path looking for these folders. Now we need to look for the files in this folder. So we do is that we copy that, click on the plus here to add, copy paste, and then do include /OpenNI. Because now we go inside the include folder and then inside here, and now it can access everything that's in this right here. And that is technically the last thing we need to do to be able to get this up and running, if I haven't done any mistakes. So let's see, we can do a little test, see if this compiles. So let's start by including let's include ofxOpenNI capital .h, and then in here we create ofxOpenNI. So now we create our Kinect object. I mean, let's also create a bool called mode. This is, we're going to use this during. So let's see. So sometimes what I do, because I had this problem in the past working with libraries, that sometimes you need to clean your build to be able to find the right structure. Sometimes you need to restart your Xcode just to be able to get the architecture working fine. So let's clean that, and then let's see if I can compile this. It takes a little bit of time to compile, my computer's a bit slow. Success. Great. So you can see we have 65 warnings, and it's finding a couple of things, but this is a bit old, an old add-on, and it might need to be updated to be able to get rid of these warnings for later versions of both Xcode and OpenFrameworks. But like I said, like you saw, it compiled. That is the main thing we want here. So we don't have any errors with our file structures, and there's no, because you can get, I got even more errors. I got like 120 errors, like this, if the file structure is wrong, everything is going to be wrong. So this is the trickiest part, getting this up and running actually. That's at least in my experience. So yeah, so we have our ofxOpenNI Kinect object here, my Kinect is already connected to my through USB, and I'm using a Kinect for Xbox 360 model, the version 1414, which is like, if you have newer models than that, they have like some sort of update on it, so you can use it with like PCs or Macs or OpenFrameworks and stuff like that. So I recommend you to get this version because it just plug and play. It was so easy to get it started. I just plugged it in and boom, got it all set up. So let's get to the fun part. Let's start coding and see if we can get a skeleton working. So let's start with making black background, and let's do the setup for the Kinect. So now we call it Kinect dot setup. This everything is coming from the library now, so we're gonna use dot to set register to true. So we want to use, so these are a couple of things that you need to set up to make the Kinect understand what we're trying to do with it. So yeah, we want to mirror it because it works in different ways. If you're doing like point clouds and stuff, you need to like, it's upside down and in reverse, so that's a couple of things that it does for you. So we do Kinect. So we need to get the depth information from it, so we need to set that up. Kinect. No, sorry. Yes, and this is what we need to be able to actually connect the user. And then we do Kinect dot start. So we do everything start and setup. We set it up before this sketch even starts. This is up and running, and we set our mode to false. This is just going to be an indicator saying, okay, if is a user tracked or not. So it's just going to be simple on and off switch. So then we go down to update, and we're going to do Kinect dot. Sorry for my bad typing. I tried to do this as fast as possible. And then we go down to draw. So here we do, let's do the simple check. So if mode is false, which is done by default when it starts. So if it's false, we're gonna say, okay, let's do a green circle. If it's false, it's a red circle. If it's true, it's a green circle. So just indicating, say, okay, it's on and off. So let's set color to red, full red, 50 X and Y, radius 10. And let's set full green, 0 blue. So there, this is just gonna make it draw a circle if mode is, if it's not true, equal to false, draw a red one, else draw a green one. And let's do, I'm gonna do a little bit of translation here because of how my Kinect is set up at the moment. So I've just been doing a little test to see, well, okay, so if you want to get it center screen, this is how I'm going to do it. So I'm going to do it a push matrix, and then I'll translate. I'm going to translate it 200 pixels in the X, down 50, and in the Z axis, going to translate it backwards 100 so we can get a better look at it. how this worked. Looks, and then we're gonna do a check here. So we're gonna track, damn it. So we're gonna say, so if connect number is greater than 0, so say if we detect a user, then do all this. So then, because you can track more than one person. So let's do, so for this example, we're just gonna do one. But say so each of the things, if this happens, so if there's someone in front of the camera doing the right pose, okay, let's do something. So let's say ofxOpenNI user. Look, see, yeah, you know what I wanted. Call it user. Call it Kinect dot get track user, and the index is in this example just 0, which is going to be technically the first one. So say if you're looping through 3 people, so you can get use tracker I, whatever you want to track. So now I'm just tracking me at this point. So let's do OF set color, and let's do full white, because we're gonna start with the lines, or the limbs rather. So then we do a for loop that's gonna go int I equals 0. It's gonna be user dot get number of limbs I plus plus. So we're gonna loop through all the limbs of the user, and we going to set up an ofxOpenNI limb. We call it limb equal user dot get and then we're gonna use a enumerator of class limb and I. No, sorry, that's not gonna be curly bracket. That mistake. So we're setting it up. So now we can actually track these limbs. So now you can say, so if limb is, so if it's found, do something. Okay, what we want to do? We want to draw it. So we're going to do a float x1. It's going to be equal to limb dot get start joint dot get get projected position. That's what we want. Dot x. So now we're getting the start of the first x. So let's do and copy paste, because I'm going to rewrite this a lot of times. So we're going to do y1 now, and we're going to do the same thing, but for the y position. And let's do that again. But now we're going to do x2, and we're going to get end joint. So it works exactly the same way, but now with the end of get joint. So by getting all these x and y values, we can now use OF draw line and use x1, y1, x2, and y2. So this is now going to draw all the limbs from the start and end of the limb, but it might not be. Let's do a cleanup so I know where I'm at. I think that is it. And let's draw the actual points. Like do the head, the hands, the elbows, the knees, the torso. Let's do all those main points that you also. So you can say if you want to track your left hand or arm, you can get all the joints as well. So let's do a. We need a 2D vector. Let's do a 2D vector. Call it pause. Oop. And let's do another for loop. Now track of the user again. So get num. But now we're gonna go through the joints. I plus plus. Let's do ofxOpenNI joint and call that joint equal user dot get joint, and we use the same thing, enumerator joint I, and this is if joint is found, same thing. So if the joints are found, let's draw them. So if these joints are found, set mode equal to true. So that if you find the joints, set it to true, so we can we know that we can indicate to that little light we created in the beginning that they're found. So let's say, let's do full green, 0 blue, and let's do a little bit of opacity so it looks cool. Let's do float x equals joint get dot x. So the same thing that we used in up here for the x and y here, but we don't get end joint. We're just getting the actual position of not the joint. So we're gonna do same thing again. Just copy and paste that. Call it y, and let's set that to y. And we want to use this. We're getting this information from the Kinect, and we want to set that into our vector here. So we're gonna do pause dot set x and y. And then we can, with this vector now, of draw circle, we're gonna do pause.x, pause.y, and the radius is 10. So now we're gonna draw a circle on each of these joints. And let's do it else. So if we fail, mode. So say we have this joint is found, but then I move too close or move too far back, it's gonna go back to false again. So, and then I need to pop out. Like so. Hope this seems to be alright, but you never know when you're live coding. But let's try this and see if it works. Look, it compiles. See, all the devices are found. See in the console panel here. See the red lights indicating. I'm gonna walk up and see if we can get my body tracked. We have success. So you can see now it's tracking my body. So I'm drawing limbs. I'm drawing I'm also drawing everything. I'm wearing shorts, so you can see that it's looking like my legs are really, really small, but so there we have it. I hope you guys enjoyed that video, and hopefully it made it a little bit clearer. So this is the basic of getting your skeleton tracking, but hopefully that is just a little, because you won't just plug and play and just get this working, and then you can get other stuff working with it. So I definitely recommend you guys checking out Box 2D, so you can do collision detections and you can do loads of fun stuff with this. So I hope you guys enjoyed and have a great day. Thank you. Bye.